Welcome again to this lesson. So this is chapter 2 of this lesson. Please, or if you're just coming, you can go back to chapter 1 where we started from and define what agentic system are. So in this chapter 2, we'll be discussing designing agent systems. So please like and subscribe to this channel. So if you like our videos, so you see more of our content. Our content are focused on agentic AI, generative AI, LLM, machine learning, or data science, data analytics, cloud computing, or enterprise integration system, enterprise solutions, and applied mathematics. Okay, so please like and subscribe and follow us. Thank you. So designing agent system. So how do you design an agent system? In chapter 1 we look at when you need to use an agent, when you need to use traditional workflow or just a traditional script or just a chatbot or Q&A, and we say that you only use agent when you have a dynamic very complex problem that a workflow or a traditional script cannot solve. Okay, and then one of the things we said there was that you should start very narrow. Do not just start building a complex architecture. uh, it will be costing you money and the time, and it may be too complex for the entire system. So start narrow, start simple, and then you can uh, increase as you integrate, so make your system very agile. So you start narrow, you choose architecture intentionally, so you have to be very intentional when you are choosing your architecture or when you are designing your architecture. And then measure from day one. So always measure from day one, because this system costs money. Every API call you make, you're paying for it. So always measure your KPI from day one. Augmented slide presentation, so architecture views. In this presentation we'll be looking at agentic architecture views, decision diagram, and practical production trade-off. All right, so design agent system, so model, tools, and values, what we have here. So number subtopic 1, start narrow, ship fast, measure early. So example, focus on cancel order instead of automate customer support. So let's look at this simple workflow. Practical momentum build theoretical perfection. Scope the first agent around one valuable slice. Let's look at this problem. You want to build an agent that will cancel order instead of automating customer support. Look at what the workflow will look like. You have a messy real world problem. You have a lot of dormant order, inoperative order. Then that's the problem you have. The narrow valuable slice. So narrow your solution into this problem that you have at hand. Then use a tool-backed agent. Design tools that can solve this problem, which are Python function that can solve this problem, and then you register these tools in your tool registry. Then the agent will now use the tool to implement structured action and give you a concrete output, and then you have your feedback. So evaluation from day one: to recall, parameter accuracy, output correctness, and task success rate. These are very, very important. So you can see how important tool calling are in agentic design pattern. So the messy problem is the starting point, and the narrow valuable slice, that is context. Okay, so narrow the problem into context, and then there's a tool for the context, and then the agent take action, implement the tool based on the context, and give you a concrete output through validation. Then you have the feedback. Core component of every agent system. 4 pillars must work together. These 4 pillars are model. You must have a model. You must have a tool to solve the problem. Okay, you must have a memory, whether short-term or long-term, working memory or RAG or any other memory. you must also have orchestration. If you are building more than one agent, okay, there must be an orchestration. So the architecture will start from user and app requests. The request may be, okay, cancel order. Then the brain of the agent, which is just like the orchestrator. Agent orchestrator is where the planning, sequence monitoring, recovery, and reasoning takes place. Okay, so that is the brain of the agent there. And then model reasoning plus decision engine is also connected to the orchestrator. And then the orchestrator pass information from the user down to memory. Maybe there is an information in the memory that can assist in giving an accurate output. So this memory can be short-term context or long-term knowledge like vector database or RAG database. Then after that, it will call tools API or local logic backend system. So tools or in the registry or local logic that has been designed, or a backend system that can assist in solving the problem. Backend system can be maybe database, or you have a local logic. Maybe you have a rule that you have designed somewhere, and then it will validate whatever the tools has applied to the context, to the problem, and then it will pass this through guardrail, evaluation, policy check, quality, security, whether there is an escalation, that is filtering what it has generated, and then after that you have your output. So weakness in any pillar break the whole system. So if there's any weakness in any of this design, to break the whole system. For example, if you fail to implement guardrail, or you fail to implement company policy, security, dedication, authorization, filtering, or profane languages and all sorts, you're going to have a response that is not good enough. Choose model and tools for the task. So there is no universal best model. Production system routes work dynamically. So there is no universal best model. So everything is just unique in their own way. So no universal pattern. So this is how task router work. First, you have routine task, small model, fast plus cheap. Then you have hard reasoning, which is large language or large model, accurate plus slower. They are very accurate, but they are slower. And then we have private control, open weight, fine tune plus host. And then you have fast launch, which are proprietary API, managed plus priced. And then you can also use local tool rules, calculations, and validators. You can use API tools, which are real-time data, RAG system, and backend action as well. You can also use MCP. MCP is part of this lesson design, which we are going to see how it works. You can use MCP, content states, structure context, and fieldwork cost. And then you can also have monitoring usage, latency, cost, and failures. So these are tasks that the agent can route to, and the specific local tools that can be used for them. So this is how agent route operation. So practical rule: use smaller model for routine work and route complex cases to larger model only when value justify it. So for cost optimization, so use smaller agent for normal task. For example, or in Claude we have the Haiku, we have the Sonnet, and we have the Opus. So if you have everyday task that Claude Sonnet can do, why do you need to use Opus that will cost you more money? Alright, single agent versus multi-agent architecture. So as we have said before, start simple, split into specialist agent only when complexity demands it. Make sure you always start simple. Then when the agent the simple agent cannot solve the problem you have, then you can now move into a specialist agent that can solve this problem. So we have single agent. So this is just like more or less like a workflow, but they still use LLM anyway. So you have a request, then you have one agent which will plan, act and respond and generate request. That is just a single agent, one agent for one operation. So this is best for narrow, well-defined task, simpler to deploy, debug and govern. Very, very simple. Multi-agent. This is from 2 or more agents working together to solve problem. So these are routes to, in multi-agent system, you have the supervisor agent, which is just like a coordinator agent that will coordinate all other agents. Then under this, you have research, you have research agent, you have the planner agent, you have the 2 user agent, and you have the reviewer agent. So this is best for complex flow with specialization, parallelism and or redundancy, but add coordination overhead. So they have complex workflow which works through coordination, which is called an orchestrator or a coordinator agent. So architecture choice drives scalability, reliability, cost and maintainability. So remember these pillars. Scalability, you must build a scalable system, you must build a reliable system, you must put cost optimization into practice, and you must make sure that your system is maintainable. So if you build a complex system that you cannot maintain, then you will just be running cost without having without generating an output or having a reasonable value that you can show off for it. So decide trade-off you will face. The best agent systems are practical, they are testable, and they are economically justified. So they are justifiable economically. So these are trade-offs that you must put into a practice. Speed versus accuracy. Real-time system want fast, high stakes domain want correct. So what is your immediate requirement? Do you want speed or accuracy? If speed is what is what you want to go for, then you have to build a real-time system that will work fast. If you want accuracy, then you have to build a deep thinking system like high stake domain one correct. So you have to go for a system that will be slow but generate accurate output. Number 2, cost versus value. So do you want a simple agent that will be affordable, that will not cost you too much? Spend more only where the outcome justify it. So spend more only where it is needed. Do not spend more where it is not needed. Do not waste API calls when you can just use a simple workflow. Do not build multi-agent system when one agent is enough to perform the task. Flexibility versus determinism. Agents adapt, workflow audit, use hybrid design. So you can combine agentic system with workflow. When you combine workflow and agent together, it becomes hybrid. So if flexibility is what you want, like you have a task that workflow can solve, you have another complex one for agent and you want to combine them, then you go for hybrid system design using workflow and agents combined together. That is hybrid design. But if you are very deterministic that or this stack you want agent to implement everything, or workflow cannot do it and you want agent, then you go for agent only. Otherwise, hybrid is cheaper and is flexible. Scale versus reliability. So scalability is the ability of the system to scale up or down when there is demand, more demand or less demand. Okay, so we have vertical and horizontal scaling. Then reliability is ability of the system to perform, to be available and to perform when it is required. So scalability versus reliability, async execution, load balancing, GPU allocation and recovery. So if you want scalability, then you go for the one that will help you, load balancing, GPU allocation. Or if you want reliability, ability to recover from failure, async execution and so on, also make sure you include all of this in your design. Final takeaway: start with a narrow valuable task, define measurable outcome, use simple tools, choose the right model, then scale thoughtfully across model, tools, memory and orchestration. Start simple, build faster, and then you know or integrate faster. Then when the situation is becoming complex, dynamic, then you can now start with multi-agent system, uh, putting all of these steps into action: scalability, reliability, flexibility and deterministic, cost and value, cost optimization and value capture, and speed and accuracy. Very, very important. So thank you for staying with me to the end of this lesson. Thank you for listening, and see you in the next video. Please remember to subscribe. Bye.